Hi friends, today's topic would be on some of the most fundamental and important concepts around the database, which is absolute necessary for data science professionals. Most people, when they come into the field of data science, or if you're aspiring to be a data science professional, often a lot of people get baffled with the amount of information that's spread across in the internet. And there are a lot of jargons that are used. For example, people talk about machine learning, people talk about artificial intelligence, deep learning, neural networks, and there's a lot of these jargons that are used. Uh, while these are definitely separate branches of the field, the broader field of data science, often what gets overlooked is a structured approach to understanding what are the most critical elements, what should be the roadmap for one to master this particular field. And that is where most people who are trying to come into this field, they kind of get lost in this ocean of different topics, different technologies, where to start. There's a lot of doubt regarding that flowing across the internet and flowing across different communities. So, our goal here is to start with one of the most fundamental things that we talk about in data science, and that is nothing but data, right? In some of our earlier videos, we have discussed about data at a deeper level. We have gone into some of the basic and fundamental concepts about data, which is worth looking at. So it's a good idea for you to look at the other videos that is uploaded on this particular channel. It's suggested that you subscribe to this channel to stay updated and notified whenever we post a new video on something that is interesting, and you can take some knowledge out of these sessions, right? So let's start off with some of the most fundamental concepts of data and databases that you need at least some familiarity to get into the field of data science. So first, let's talk about what are the different types of data repositories, right? So let's talk about the different types of data repositories. And data repositories are places where you can store the data. The first one, and one of the most popular repositories, is known as the RDBMS, or Relational Database Management System. There's one second type known as data warehouses. Also, we tend to use a lot of times in retail and the CPG world, we often deal with what we call as transactional databases. And there are also some other advanced data systems that we will cover. Now, let's first understand what a RDBMS is. RDBMS is a relational database management system. Now, let's break it down into simpler terms. What do we really mean by a relational database? Now, data often is stored in the form of tables, and each of these tables have a unique name to be able to identify and differentiate one table from the other. Each of these tables do have certain features or attributes better known in the field of databases as columns or fields. And there are also a number of rows, or what is known as tuples. So a relational database is often represented through what is known as an entity relationship data model. This is a kind of a semantic data model. We will come into that gradually. Imagine you have two different tables, and the two tables store the following data. You have information about different customers and their demographic information. For example, what is their age, what is their gender, what is their name, where do they stay, do they own a car, do they own a house, and all of those demographic data is stored in a demographic table. Similarly, you can also have a transaction table where you are looking at what are the different transactions that a particular customer has done at a particular store. So this kind of data would include things like, where did he go, or what did he shop, how many items, at what price, This kind of information. Now, what relational database talks about is that there's a relation between the demographic table and a transaction table. So as you can see, there's a common key out here, which is the customer ID in both the tables. And this is one key, which is a key is basically a unique identifier in multiple tables, which helps us to relate one table to another. And relational databases are some of the most commonly used data repositories, and there are queries with the help of different query languages. So, in the case of RDBMS, SQL is one of the query languages that is used to fetch or retrieve data from these kind of tables that exist in databases. So SQL is one of the queries which is used to fetch or retrieve data from these kind of relational tables in a RDBMS. There are different ways of manipulating data through, joins. You could, basically combine two data sets. You could append them. You could join them. You could summarize in whichever way you want. But that's not in the scope of this particular session. We would be possibly covering that in one of our other sessions, or a very good site that you can look up is the W3 Schools, where you can go for SQL and try to go through their entire modules on SQL to have a more familiarity with how the SQL language works on the different kinds of relational database. I mean the relational databases and relational tables. Let's look at what a data model is. So basically a data model that we have brought up in the previous slide is uh, a model basically which defines how the data are interconnected to each other and how these data are stored or processed inside the database management system. Now there are two broad types of database or data models. The first one is called the entity relationship model, or in short the ER model. In this particular model, we can think of the tables as entities. Suppose there are these two entities, E1 and E2, and each of these entities have a set of attributes denoted by 1 to n, and in this case, let's say 1 to m, m, right? And there exists a relationship between these two entities. Okay, so this is given by the entity relationship model. Now imagine that you are looking at a customer database, for example. So in this case, an entity would be your customer. And what would be his attributes? That could be things like age or income, gender, and things like that, right? Now, one important concept here in looking at entities is the cardinality. So here, for example, we are looking at a one-to-one relationship. Now, there could be many possibilities in terms of relationship among entities. It could be, excuse the format. Okay, yeah, so here it could be one to one or one to many. It could be many to one, or it could be many to many, right? So these four kind of mappings are possible among the different entities. Now the second type of data model is what is known as a relational model. And what a relational model states is that a table in this case is nothing but a relation. So you have this table, and this is what is known as the relation. So here the columns can be thought about as the attributes of your data, and the rows are also called tuples or rows. And the relationship that's being shown between the attributes and the tuples. This relationship is given by a table. Okay, so now let's move on to the next type of data repository, which is a data warehouse. Now, a data warehouse is a repository of information gathered from different sources stored within a single schema and at a single site. Now, we'll talk about schema in one of the subsequent slides, but for now, let's take this brief example. Suppose we are looking at a large MNC, right? And their data is stored at different countries at different locations. Okay, now imagine the CEO of the company wants to look at basically summarized sales reports for all the countries to see how the sales distribution looks like across the different regions. So you can imagine this situation like, for example, you have database A, database B, database C out here at different locations. And what you are trying to do is you want to fetch a summarized report from these different databases. So there's a whole bunch of processes that needs to be performed out here, which is known as the ETL process. And the ETL process basically consists of a few steps. So ETL stands for extract, transform, and load. And this includes things like cleaning of the data. It includes things like integrating the data. And we will cover each of these terms. So why cleaning is required is because data often in the raw form is not really useful. So if you want to mine the data, if you want to come up with information from the data, it's very much required that you clean the data in a way or in a format that is more readable for the end objective that you are trying to solve. Similarly, data could come from multiple sources, and having them from multiple sources doesn't allow for us to be able to create meaningful summaries out of it, which is why there needs to be an integration process which combines all these data sources, tables from the different sources into one place. And there's this important concept of transform, which we'll talk about, which is also a part of the ETL process. And then we have load, and then we also have data refresh to make sure the data that we are looking at is the most updated. Now, once we have this entire ETL process done, then this further goes into what we are calling as the data warehouse. So what this data warehouse does is it stores the aggregated data from the different sources, right? For example, you can think of this as you are doing certain aggregation like a sum on sales. So you have sales information for each of the different regions, and you have combined all of those data now, and you are trying to look at the summarized total sales across the entire data set. So you are basically aggregating at this stage. Now, how this data warehouse is now used is basically you have some end user out here who is hitting this particular data warehouse through queries. Okay, so you are using certain kind of queries and query languages to fetch and retrieve information from this particular data warehouse. Okay, now let us look at data warehouse and data mart. So although the two terms are very similar and often confused, there's a slight difference between a data warehouse and a data mart. A data warehouse is more like a broader concept where the data is stored across all the objects. For example, if you are dealing with data which involves all the customers of a particular brand or of a particular company, then you are essentially looking at a data warehouse. On the other hand, if you are looking at a data which is more limited in scope, For example, something if you're looking at different departments of a particular company, maybe you are looking at the apparel business unit, maybe you are looking at the fashion accessories, whichever department if you're looking at in a smaller isolated way. So data mart is more appropriate in that case. One of the benefits of data warehouses is that it allows for online analytical processing of the data. So these kind of operations, what they do is they allow for looking at the data or presenting the data in different summarized forms. So how this helps is you can have a holistic picture of the entire business from all angles. You can slice and dice your data from different angles and take a look at it, right? So imagine that you are looking at, for example, let's say you are looking at the yearly dollar sales, and in terms of year you have 2010, 2011 up to 2019, and you have some dollar sales, $100 million, $200 million, and maybe $500 million. Now how a data warehouse would help you is basically if you wanted to now look at a drill down report or drill down version of this data, you could, through this online analytical processing, this feature, you can now look at a more customized view of the data. For example, you are now looking at month of the year and dollar sales. So you're looking at Jan of 2010 and you see that the dollar sales is maybe 30. So this kind of flexibility is offered through the OLAP technique on data warehouses. Similarly, you can also do the opposite, which is what we call as the roll-ups, where if you have the data at a more granular level, for example, you have the data at maybe a quarterly level, and you have dollar sales here for quarter one, quarter two, similarly for the different quarters of different years, and you have a year column out here. For different years, you have different quarters and their sales values. You could easily roll that up into a more aggregated view where you just look at what is my total dollar sales by each of the years, right? So you have year here, you have dollar sales here. So you say 2010, you sum up the dollar sales across all the quarters from the left hand side table, right? So this is what is facilitated by the OLAP. Next, we look at the transactional databases, and this is a common type of data repository which you would come across while looking at retail or CPG or any kind of transactions that happens in the stores. You would store the data in what we know as transactional databases. Now, in transactional databases, each record represents a unique transaction, right? So there's a unique trans ID, or you could name that column or attribute in any different way. And what this unique identifier tells us is that this is one particular unique transaction of a shopper or a customer. Now, there are also additional details in the transaction level database, which is very common, which includes who is the customer. Often this variable is called cust ID or simple customer ID, things like that. Now, a transaction table also has where does the customer go, to which store, what does he purchase, which is like what all items does he purchase, what is the timestamp of the transaction, what is the price per unit, how many items did he buy, and many such information. Imagine yourself going to a store, picking up bread, butter, maybe yogurt, and these kind of items. So all those history of the transactions are being stored in transactional databases. Often transaction is extremely useful along with other sources of information such as the details about the item. What is the item? What product is it? Which department or category does it belong to, right? And often, in addition to the transaction table, we would also have details about the customer demographics. For example, what is the age of the customer? What is his name? Or what is his occupation? What is his level of income? Does he own a car or a house? How many children does he have? So this kind of demographic information about the customer along with the item information and the transaction history helps us perform a lot of analysis using this kind of transactional data. Often we use these kind of data for studies dealing with customer level segmentation or market basket analysis, where we are trying to look at different product affinities and which all products go hand in hand together. So if you see, often if you go to a store, on the shelf you find certain products kept together always. So there's a particular pattern of keeping these products, and there's a logic behind it. So that kind of a study is done through market basket analysis. And why this is useful is this often helps the retailer to understand if they can co-promote certain products, how can they do the pricing, and how can they promote certain products. And it also helps the manufacturer in a way to understand what are the products that goes hand in hand together, and if they can come up with necessary substitutes or complements to fill in the gaps existing in the market, right? Now there are certain other categories of uh, data repositories. One of them is the object relational database, and objects having similar properties can be grouped within a class. So each object in this case is thought to be an instance of a class. For example, the class customer here would have variables such as customer ID, age, income, etc. Right. So here we can think of customer ID 1, customer ID 2, and similarly customer N, each of these customers as the different objects. So each of these customer IDs can be thought of as objects, and what forms this entire group of these customers as objects is known as the class. For example, now out of these objects you are trying to find out a subgroup or a subset from this particular group, that is known as a subclass. For example, now you are looking at your transaction table and you are looking at all the customers. But for your particular analysis, let's say you just want to focus on, or you just want to concentrate on your high value customers or customers who are loyal. Now, in order to do that, you would have to have a definition of who are your high value or loyal customers. Suppose you are trying to define your high value customers just based on the total transaction value or the total sales amount that they generate, the revenue that they generate over a period of time. If that is the case, then you would put a filter, or you would basically look at only those customers, let's say up to maybe customer K, where K is less than N. You would just look at this particular subclass or subsegment of customers who are your most loyal or high value customers. Now, there are also other databases in here, and some of these data repositories are: one is a temporal database, right? What a temporal database is basically, it contains time related attributes. Okay, so if you have time related attributes in your data repository, that would be more suitable to be called as a temporal database. Similarly, you could have a sequence database, which is also another kind of a repository where you are storing sequences of different ordered events. Then you could also have a time series DB, or database in short. The major difference between a time series database and a temporal database here is that in case of a time series, we are looking at the sequence of events, but we're looking at them over repeated measurement of time. Okay. There's one other kind of a data repository, which is the spatial database. So here, imagine that you are looking at a geographic location. Maybe you can think of this particular map out here, and you are looking at, let's say, satellite images, right? Or think you can also think about that you are looking at um, the RGB pixels. So if you're looking at a particular image, it's being measured in terms of pixels, right? And those pixels, if you're looking at, it could be represented in a spatial way. So that kind of data is stored in a spatial database. You could also have what is a text or a multimedia database. As the name suggests, here your data could be things like emails, right? It could be HTML codes or HTML text, XML files, audio, or even videos, right? Now, also we could think about one other important type of repository, which is the streaming database or streaming data repository. Here, what we are trying to do is, what this particular streaming means is that, the process is that there's this uh, input stream of data, and there's this particular machine or window which basically takes this input and generates some kind of output in a real-time fashion or in a dynamic way. Imagine this kind of data to be, for example, the network traffic, the internet network traffic, or you could think of the real-time stock data, and these are suitable data to go into the streaming type of database. Now, few other important concepts to talk about here in this context of databases is what we call as the REST framework. Right? So it's very important to understand what is the architecture and what is the structure of certain databases, how it works, and what are the important properties of these databases that make sure that we are looking at data which is of high quality, which is of good quality, and there's no compromise with regards to that. So let's talk about what REST framework means. So the term REST stands for Representational State Transfer, and this is an architectural style designed for API, or better known as Application Programming Interface. Now, it's not necessary for you to understand all of these terms that we discuss about at this point, because that's not essential. What we are trying to discuss here is, so that you at least have some familiarity with these terms and can hopefully understand some of the basic fundamental underlying concepts for these particular databases, right? Now, API or Application Programming Interface is a web service which conforms to the architectural features of REST. Now, what we mean by that is, so this is how what an API structure is like. Let's think of process here, which is the web server out here, and suppose in the front end, so this is your browser. For example, you are looking at Google Chrome, so this is your browser, this is your front end, and you are trying to run an application from the front end. It could be any application that you are trying to run. So what happens here is that, and in the back end there's a web server which basically stores all the data, or you could have a database out here where you are storing information. What you are doing essentially here is that you, as a user, you press a button on the front end application. So here there is a particular piece of software known as the client, which interacts in the backend with this web server. So what it does is it sends a request to the web server once you click on a button on the front end, and it sends this request. This particular request is known as a GET request. So all you are trying to do is get some information out of the web server, and once that information is processed and available on the web server, it sends this data back again to the front end, and this method is known as post, right? So this particular front end is calling certain information or triggering certain action from the backend, and it's basically rendering the results that needs to be shown on the front end. So there are different kinds of HTTP protocols that you need to be at least familiar with. You might not need all of these, but you should at least know that get what is the purpose of get, what is the purpose of post that we mentioned out here, right? And the principles of the REST framework is to create a stable and a robust user end application, which is also simple. So two of the major principles of this framework are, the first one being a client and server kind of a model. So here your communication between the front end and the back end is facilitated through a client and server communication model, right? The second thing is the requests that we provide. It could be a GET request if you're trying to retrieve information from the backend or the web server, or it could be a POST request where your results are being rendered on the front end. These kind of requests contains all the necessary information for the web server to respond. So the web server would basically be able to respond to your queries if you have written the queries in a specific manner, right? And that is where the HTTP protocols come into the picture. So there needs to be a specific format in which you need to write the queries to be able to fetch the required information that you are looking for. Otherwise, the results won't come properly. The third principle is what is known as caching. What caching means is, how caching rather helps is, it's more like in a way you can think of a cache as a memory, a temporary memory, where whatever information you are passing over the server or through the server, that remains stored in this temporary form. So this particular principle avoids duplication of information or duplication of request. So if you tend to submit the same request more than once, it doesn't allow, because your information is already stored in the cache memory, right? And the last one is that this particular framework is also layered. When I say layered, what this means is that this framework allows multiple layers. And what the multiple layers help us with is, it helps this entire framework or this architecture to be scalable. Okay, so I hope you have at least some familiarity with the REST framework. This is a very broad topic, and whenever you are trying to build an application or if you're dealing with APIs, it mostly runs on this principle of REST, and you need to have a thorough understanding of REST if you're dealing with those particular topics. But for this particular context, we do not need to go into that much of depth. It's just a basic overview, and you can do some basic research in Google to find out more about this particular framework in case you are interested. The next important aspect of a database is what is known as CRUD operations. Now CRUD stands for create, read, update, and delete. This is more like a just a moment. Yeah. So this is more like a cycle rather than an architectural design, unlike the REST framework that we discussed. So you can imagine this type of cycle to be okay. Let's talk about an example of an e-commerce store, right? So you have a login button on an e-commerce store. Now what happens is you have this particular login button to be able to log into your particular e-commerce site. Now you have different such buttons. For example, you have a create account button. You could also have an update account button in case you want to update your account details. Maybe you have changed your address or your phone number or things like that. And you would also have a cart button, right? Now in this cart button you could add items or you could also delete items. So you can think of this as the operations on an e-commerce website. You are creating something here, you are updating something here, maybe you are having to delete some information from here. So this is the kind of cycle that is often applied in reality in the applications that we see mostly, right? And a database supports such operations, which is create, read, update, and delete. And some of the properties of CRUD are again that these particular properties, create, read, update, and delete, how they help is they help us with persistent data storage. Okay. Now, in terms of databases, we also would come across SQL and no SQL types of databases, which are two broad types of databases out here, right? So let's see what these two type of databases really mean. We initially introduced the concept of RDBMS, Relational Database Management Systems. And these systems are like Postgres or MySQL, which is an open source. You have Oracle, you have MS SQL Server, and certain other such kinds of databases, right? So SQL is the full form of SQL is structured query language. So this is a query language that is used to fetch the relevant information from any of these RDBMS storages, like any of these particular databases, right? So what distinguishes an SQL type database from a no SQL type databases? Firstly, an RDBMS is a table based structure, right? And it's vertically scalable. It has a particular schema and it needs specialized hardware. It's more applicable for situations where complex queries are required. On the other hand, no SQL type of structure is majorly applicable for distributed data storage. For example, you are looking at real-time applications which use mostly streaming data like we saw previously, or if you're looking at big data, data which is very large in volume, which maybe comes from varied sources where there's a lot of velocity, lot of variety. In those kind of scenarios, no SQL kind of a databases is more applicable. A distinct feature of NoSQL databases is that there's no fixed schema. Now we will come to this concept of schema and what we mean by schema, and we'll go into that in the subsequent slide. But for now, just remember that we do not have a fixed schema in a NoSQL database. Now it doesn't mean that we do not have a schema. What it says is that there's no fixed schema. And also this is easy to scale. So the name NoSQL does not really mean that this is not a SQL query, or this doesn't use a query language at all. What it rather means is that it uses no definite query language. So you could use multiple query languages depending on what kind of NoSQL database that you are looking at. So unlike a RDBMS structure or a SQL database, here there's no table structure. It's rather a document type of structure, or a key value type of a structure, or it could be thought of also as a graph database, right? Unlike relational databases, NoSQL database is horizontally scalable, and this doesn't have a schema that we mentioned some time back. Also, a NoSQL database needs commodity hardware, so there's no need of specialized hardware which comes at a high cost. There's no need of that. You can just use basic commodities hardware or computers to be able to operate on NoSQL databases. And one of the major things here in NoSQL database is that this is not ideal for complex querying, right? Unlike SQL kind of a database. And this is more suitable for hierarchical data storage. And this one of the benefits of NoSQL database is that this is open source. Now, some of the NoSQL databases are popular databases are like MongoDB, you have Redis, you have Neo4j, then you have Cassandra, and you also have HBase. These are some of the extensively used and most popular NoSQL databases. Now, as we introduce the term schema, and we said that there's a schema for SQL databases, and there's no schema for NoSQL databases, no fixed schema for NoSQL databases. Now, what exactly is a schema? Right. So a schema is, you can think of the schema as the raw skeleton or the raw bare bones structure representing the logical view of a particular database. So what it contains is, it contains different details about the entities and the relationship among these entities. Now, if you remember, we discussed about the ER model, which is the entity relationship model, and we discussed what entities are. So just to refresh your memory about entities, we can think of the customer database, and over there customer ID or the different customers can be thought of as the different entities, right? And right now you can think of this as, suppose you have a logical schema, and here you have relationships and attributes among the entities. Now, if you combine these two, what we get is a physical schema, right? So this is also, excuse me for the bad way I drew this line. Just a moment. Okay, so here we go. Imagine that this particular type of box gives us three different views. This is the logical schema view. This is another view which just shows us about the relationships and the attributes. And on the extreme right, we see a third view, which is the physical schema, right? This particular diagram is known as the schema diagram. And this is often synonymously used as ER model, which we also saw in one of the previous slides. So one important point to remember here is that being schemaless does not mean that there's no schema. All that means is that there could be no fixed schema, or in other words, there could be multiple schemas depending on what is the kind of NoSQL database that you are actually looking at, right? Important concept in database management system is that of ACID transactions, right? Or when we call certain transactions to follow ACID properties. So ACID is a property, and a transaction in a database can be thought of as any activity such as read. You are reading a particular data, you are maybe updating a certain data, you are writing, modifying anything to do with the data in a particular database. So that is what is referred to as a transaction in the context of a database, right? Now, ACID properties is what makes the database a desirable structure to support end user requirements, and this is absolutely an important piece of understanding that one needs to have to be able to figure out why is the database, the RDBMS structure, how does it guarantee that the data that is stored inside this kind of a structure is considered to be good. And it's because that it follows the ACID properties. Now what ACID means is A stands for atomicity. What this rule tells us is this is also known as the all or nothing rule. What this tells us is that a transaction occurs at once and there is no halfway or a partial concept. So what this means is that if a particular transaction is aborted, then there is no change in the database. On the other hand, if the transaction has been committed, that is, if the transaction has started processing or taken place, so you have pressed the submit button or the run button on the interface, and you have submitted the particular code and the code has been committed in the backend, then you should expect a change in the database. So you can imagine a real life situation where you are trying to purchase a product and you have swiped your credit card or debit card and the amount has got debited from your debit card or credit card, but the transaction has failed, right? So that is one example where this kind of a concept comes into the picture. The C for ACID stands for consistency, and this refers to the correctness of the database. Now, as an example, think of one particular transaction, the first transaction, where you are trying to sum up two numbers. That's my bad. Let me erase that. Okay. Suppose you are trying to add two numbers, 500 and 400, and you have got a sum of 900, right? And then you had a second transaction that you had done where you have changed the first number from 500 to 300 and the second number from 400 to 600. Now, even after that, the total sum of this is still 900. So what this example tells us is that no matter whatever changes you are trying to make in the individual elements in a particular transaction, the total or the entire denominator or the total should always be consistent. What this means is that the database should be consistent before or after carrying out a transaction. Because unless that unless the initial stage is restored or this is guaranteed, then the whole database and the whole data in the database will be questionable, right? The third important property is that of isolation. Now, isolation is to do with multiple transactions can occur without loss of consistency. So, what this means is that if you have done one particular transaction here, and this particular transaction is, let's say, you have initialized a value of 10 to this particular variable x, and then what you have done is you have maybe updated that to 10 minus 5 as 5, and then you are reading the variable x, right? And on the other hand, there is somebody who is uh, trying to use or refer to the same variables at a different from a different place. So all he is doing is he's just trying to read the value of x. So if he's doing that, he would read the value of x as 10, right? And not 5. The other concept is that of durability, and the D in ACID stands for durability, which is the notion that the data changes are written in files which are permanent even if the system fails. So what that means is that the entire database that we are looking at is non-volatile in nature. Non-volatility, right? Okay. So similar to the ACID properties that we looked at for SQL databases, in the NoSQL world, the data security notions and the notions of accuracy are less of a priority. Here, more emphasis is rather laid on the scalability. So here, the principles are different from that of ACID. For a NoSQL database, what we are looking at is known as the base consistency model. Base stands for basic availability, where we are saying that the database should be always up and running. So there shouldn't be any downtime or system latency. It should also ensure that it maintains a soft state, which is the state need not have to be consistent all the time. And it should also adopt to the principle of eventual consistency, which is to do with lazy execution. That is, that the consistency might not be visible immediately as soon as you carry out a particular transaction, but over a period of time, it definitely should achieve consistency. Now, there's this trade-off between acid and base, the properties of SQL and NoSQL, and as you would have probably understood by now, that there are certainly trade-offs. While the SQL kind of a database, is puts a lot of emphasis on data accuracy and consistency, all of these principles, the security concept. On the other hand, a NoSQL database focuses more on the accessibility of the database, right, and more on the scalability. So a little bit of inaccuracy at a few specific places or eventual consistency is still acceptable in a NoSQL database, but it gives up some kind of security and accuracy in that particular fashion. The next concept is what we are calling as sharding, and this is a concept of database partitioning. What this does is basically, if you are looking at a large database and you're trying to divide that into smaller parts, so you have a large DB and you are trying to break it down into smaller parts. So this entire process is known as the concept of database partitioning. Okay. So imagine that you are having a table of customers, So you have information like the customer ID, his country, things like age or income, things like that. And what you're trying to do here is that you want to query only the customers whose country equal to USA. Now imagine that you have this entire database or this entire table for all the customers across all the different countries from all particular regions of the world. Now if you were to query on this particular table and just pick up customers who belong to country USA, that would definitely take a huge run time, and that is not exactly what you want, right? Now imagine on the other hand you have individual tables for customers for the different countries. So you have USA, and all the customers stored here. Similarly, imagine that you had another table out here where you had customer ID and country, maybe Australia, somewhere else. Now, if you were to use a query on this particular table instead of the entire table, the query would run much faster, right? So this concept of database partitioning, all it does is it makes the database smaller, faster, and easily manageable. And hence, what it does is it reduces the cost of each of the transactions. Now, one important concept that we came across while talking about uh, SQL and NoSQL databases is that of horizontal and vertical scalability, right? So if we go back to the slide on databases SQL and NoSQL, SQL is a vertically scalable structure, whereas NoSQL is a horizontally scalable structure. Now, what exactly do we mean by that? So let's understand the two structures, the two scalability structures in the following way. When we are discussing about horizontal scalability, what we are saying is that suppose you have this particular machine or a computer that you are working with. Now, if you want to increase the power of your system, what you are able to do is you can add different other systems or computers to this network. So if you're adding these computers, this is a horizontally scalable architecture. On the other hand, if you are looking at a vertically scalable structure, what you are doing is if you were to make your system more powerful, instead of adding different computers to this network, what you would essentially do is you would add all of these components individually to your machine. So you could imagine that to be a vertical stack. You are just increasing the hardware, you are just increasing the RAM size, you are increasing the disk space, a lot of those things. Now, what are the different pros and cons of each of these structures? A horizontally scalable structure is more time intensive because you have to add more systems and more computers to this entire network, right? And this is often difficult to implement. And most importantly, this is also a costly and expensive solution, right? On the other hand, if you're looking at a vertically scalable structure, comparatively, it's easier to implement. It takes less time and it's a cheaper alternative. So I hope you have understood at least some of the basics about horizontal and vertical scalability in databases. And this is one important concept while trying to, well, you do a lot of things around databases where if you are getting introduced to big data, or if you're dealing with multiple database structures, this concept would come in really handy. This kind of a basic familiarity with what exactly horizontal integration or scalability means when it comes to the database structure, or what exactly a vertical stack, a vertical scalability means, and what are the pros and cons, would be very much essential when you are dealing with different kinds of databases, their architectures. If you're trying to find out what structure is more efficient and which structure is more scalable, if you are trying to develop that entire architecture for a particular client or for your particular business, this concept is very fundamental that you would need. Okay, so that brings us to the end of this particular session, and that's all that we had to discuss today. I hope that you have learned something new. So definitely, I would say do not, uh, you know, forget to click on that bell icon and the subscribe button to stay updated about our new classes and sessions. So stay tuned, and we will definitely catch up soon. Thank you for watching.